Bismillahirrahmanirrahim. Today I like to talk about properties of congruent segments. I like to talk about them, and I actually also like to do some proofs using these properties, but I'm not sure if we get an opportunity to do that. We might have to save that for next time. The reason is because you kind of really have to know them to be able to use them. So I want to not only talk about them, but kind of memorize them so we can use them until next time. So these are built on the properties of real numbers, which I have listed here before you. If you recall, these are properties of real numbers. There's addition property of equality for real numbers and subtraction property of equality. So this should really say properties of equality. So properties of equality for real numbers. So property of equality for real numbers, addition property of equality for real numbers, subtraction property of equality for real numbers, multiplication property of equality for real numbers, and division property. So these are the properties of real numbers which we have talked about before. And if I were to say, what's the addition property of equality for numbers? This would be if A equals B, then A plus C equals B plus C. Now, these are pretty intuitive enough, right? So if I say addition property of equality is A equals B, then A plus C equals B plus C. Now, if I ask the students to relate to me the addition, all these properties of equality for real numbers, I don't get something like this. Rather, I get something like this. So this is a property of the real numbers according to students. So what is the addition property of equality numbers? They can't articulate it, although they intuitively understand it. There's a problem with that. The reason is when you cannot articulate your knowledge like this, it's hard to develop proofs, and you can't really communicate your proofs, and you can't build proofs if you kind of only know the stuff half-baked, so to speak. So you really kind of have to know this. So I want to spend some time reviewing this material so you can actually articulate these thoughts in a precise manner as is shown in this particular picture. So if I asked you as a student, what is the addition property of equality for real numbers? You should say the addition property of equality for real numbers states that if A equals B, then A plus B equals B plus C. That is within your abilities as a student. That should be within the abilities of a student. Because to this we're going to add today, and this is how it's going to look after we're done. Because today we're going to add to this particular list properties of congruent segments. But I'm not inclined to add to this if you can't really articulate these, because then it's going to only get more complicated, isn't it? So our job today is to not be like this, but rather our job today is to understand this and be able to articulate these properties of real numbers, and also add to this the properties of congruent segments. All right, so let's get to it. Now, what I'd like you to do is that as I'm going through these, try to articulate them, and in other words, enunciate them, speak them out, so you can say them. Say them 1 time, 2 times, 3 times, however many times it takes for you to actually be able to say this comfortably, so it comes out of your mind like fluently, as if you've known this for a very long time. So if somebody asks you, what are the properties of equality? I should really say properties of equality for real numbers, okay? Then you should be able to list these. Right? They are very intuitive, and they seem like very easy to remember, but you should be able to express them. Then you should be able to regurgitate this out. You should be able to say these. So let's go through them one more time, and then to this we'll add some more today. So addition property of equality. So if I were to ask you what's the addition property of equality, you should be able to say the addition property of equality for real numbers. You have to say this. Addition property of equality for real numbers. I'm just writing the first letters here so you can think with this. So addition property of equality for real numbers states. So you should say that. States. Addition property of equality for real numbers states. Addition property of equality for real numbers states that. Now, this is an elegant way of expressing yourself, because it's really not, we think that this kind of thinking where the student goes this is acceptable, but no, you can do better than this. So we want you really to be able to do this. So you should be able to say addition property of equality for real numbers. Addition property of equality of real numbers states. You can say, it's a big fancy word, states. Addition property of equality states that if A equals B, because this is about real numbers, that if A is equal to B, if you have two real numbers are all the numbers that you know, except for the complex numbers, if you have studied that before. So basically all numbers that you should know, so all the numbers that you work with. So addition property of equality for real numbers states that if A equals B, then you can add something to both sides. Then A plus C is equal to B plus C. If A equals B, then you can add something to both sides and of this equation, and both sides will still be able to will be equal to each other. So that is what you should be able to express. So when somebody asks you what's the addition property of equality for real numbers, you should say addition property of equality for real number states that if A equals B, for two real numbers A equals B, if A equals B, then A plus B is equal to B plus C. All right, because today we're going to add the congruent segments. As they say, what's the reflective property of congruent segments? You should say the reflective property of congruent segment states that segment AB is congruent. The segment AB segment is congruent to itself. So that's why, because a discourse, a conversation in geometry is very difficult unless you're able to enunciate, articulate these properties with confidence. So that's easy enough, right? So we have addition property of equality for real numbers. Now, if I were to ask you to state what is the subtraction property of equality for real numbers, you should be able to say the subtraction property of equality for real numbers states that if A is equal to B, then A minus C is equal to B minus C. That is, if two numbers are equal, you can subtract something from both of them and the resulting quantities will still be equal. The subtraction property of equality for real numbers states that if A is equal to B, then A minus C is equal to B minus C. In a similar way, the multiplication property of equality, I hope you understand the pattern now. If somebody were to ask you, what is the multiplication property of equality for real numbers, you should be able to say the multiplication property of equality for real number states that if A is equal to B, then A times C is equal to B times C. And in the same way, the division property of equality for real numbers states that if A is equal to B, then A divided by C is equal to B divided by C, and here you must add that C cannot be equal to 0. So if somebody were to ask you to state the division property of equality for real numbers, you can't go like this. You can't go like, that's not acceptable. You have to say if A is equal to B, then A divided by C is equal to B divided by C when C cannot be equal to 0. You cannot divide by 0. That's not defined. Okay? So addition property of equality for real numbers, subtraction property of equality for real numbers, multiplication property of equality for real numbers, and division property of equality. And if you were to write these down, you should write, say, the addition property of equality for real numbers states that. You should spell it out. I'm just writing the first letter so it's easier for me to speak, because it's hard. It would take forever for me to write everything down, right? So addition property of equality for real numbers states that if A is equal to B, then A plus C is equal to B plus C. That is an expectation from geometry students. That's you should be able to say that. I mean, it's not that hard, right? I mean, it's very intuitive, but you just have to get used to the knowledge. It gets used to the vocabulary that's used to express these thoughts. Okay, so that is the addition property of equality for real numbers, subtraction property of equality for real numbers, and multiplication property of equality for real numbers, division property of equality for real numbers. And the next three are very important. I didn't write down the whole thing over here because they get kind of cluttered. But the reflexive property of equality for real numbers, symmetric property of equality for real numbers, transitive property of equality for real numbers. And you must really, really understand this. So reflexive property of equality for real numbers simply says that a number is equal to itself. I mean, everybody knows that, right? That's what you say. Yes, correct. Everybody knows that. So, but nevertheless, that's the reflexive property of equality for real number. So if somebody asks, what's the reflexive property of equality for real number? You say the reflexive property of equality for real number states that A is equal to itself. A is equal to A. A number is equal to itself. Now that's different from symmetric. Now, students confuse these two all the time. They confuse the reflexive. So what's the reflexive property of equality? They go to this one. Symmetric, they go to this one. So they confuse these two properties. The symmetric property of equality for real numbers states that if A equals B, then B is equal to A. So we can't get these mixed up. So reflexive property of equality for real numbers says a number is equal to itself. Symmetric property of equality says if A is equal to B, then B is equal to A. So symmetric property of equality for real numbers says, so watch this, symmetric property of equality for real numbers states, gotta know that. So symmetric property of equality for real numbers states that if A is equal to B, then B is equal to A. You must be able to express that. Symmetric property of equality for real numbers states that if is A equal to B, then B is equal to A. And then finally, the third one here of these three pairs, right? So these are particularly important. So reflexive, symmetric, and transitive property. So reflexive, symmetric, and transitive property. So then finally, if A is equal to B and B equals to C, then A is equal to C. So transitive property of equality for real numbers states, transitive property of equality for real numbers states that, watch this, if A is equal to B and B is equal to C, then A is equal to C, like this. So transitive property of equality says if A is equal to B and B is equal to C, then A is equal to C. Okay, now here I'm going to pause a little bit because we're going to talk about this particular transitive property of equality a little bit, because this is one of the more important properties that we use again and again and again. First, let's do like halves of this, memorize this very carefully. So the transitive property of equality for real numbers states, okay, I'm going to try to write this neatly because I'm going to need this, states that if A is equal to B, all right, and I'm going to write this here, B is equal to C, all right, then I'm going to say then A is equal to C, then A is equal to C. Okay, so I'm going to write it like this. So transitive property of equality for real numbers states that if A is equal to B and B is equal to C, then A is equal to C. I like to bring a couple of things to your attention here. Transitive property of equality says A is equal to B and B is equal to C. So you have to understand there's two separate equality statements here. There are two separate equality statements here, but what's special about them is that there's something common to them, that there is a overlap. So there's some overlap, right, or something that's common to both of these statements. A is equal to B and B is equal to C. So whatever overlap is, right, it's kind of like a bridge between A and C. So the overlap or something that's common acts as like a bridge between the other two things. So A is equal to B and then B is equal to C. So B here is kind of like a bridge for A and C, isn't it? Okay, so that's very, very important to appreciate, because in proofs this not always as readily apparent. So is A is equal to B and B is equal to C. So whenever you have the two statements of equality like this, whenever you have statements of equality like this, the two separate ones, if you see overlap, you should always think, perhaps I can use the transitive property here. So transitive property of equality for real numbers, and we shall see transitive property of equality for congruent segments today and for angles in the future, for etc., etc., etc. It has two statements with an overlap, something that's common to both of those statements, which acts as a bridge for the other two things in the statement. So that I like you to appreciate. If A equals B and B is equal to C, then A is equal to C. So here the B is the overlap, and the resulting two quantities here, the remaining two quantities here, A is equal to C, like this. Now, that's one thing I like to suggest to you, that you should always be looking for overlaps or something that's common between two equations or two statements. Now, the other thing I wanted to suggest to you, the statement is written like this: if A equals B and B equals C. But the statement could also have been written like this, okay? If A is equal to B and C is equal to B, okay, then A is equal to C. Okay, now that's interesting, because if A is equal to B and then B is equal to C, but this is kind of basically you're using the symmetric property and switching this around. So sometimes students are kind of like, don't see this. They see this, but they can't see that you can also use transitive property of equality. So the idea here, again, you should always look out for any statement that has something in common. Here B is common over here, right? And here B is common like this. So anytime you have two things common like this, you can use the transitive property to make the other two equal or congruent. You follow what I'm saying? So don't be kind of like distracted or caught unawares if they're not written like A equals B, B equals C. So you're thinking if A is equal to B and B equal to C, and then A is equal to C. What if the statement is written A is equal to B and C is equal to B? Then you're like, can I use the transitive? Of course you can use transitive property of equality for this, because there's something that's common to both of these statements. So you should be aware that they may not be written in this particular pattern, but because you can always apply the symmetric property to bring them in the pattern if you wanted to. That is to you that is more readily apparent to you. So don't be fooled if in a proof, if given statements are not in a pattern that you are accustomed to as written over here. If it's A equal to B and B equal to C, then A equal to C. So now again, so let us get very, 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 very good at articulating this and enunciating or being able to state these statements verbally. So if a teacher asks you, what is the transitive property of equality for real numbers, you should be able to say, if the transitive property of equality for real numbers states that if A is equal to B and B is equal to C, then A is equal to C. Now you should be able to say that. If you say that, you'll make your teacher very happy and proud. I mean, they might, they'll be very happy. But we should all be able to say that. All the students be able to say that. And finally, the last two properties that I like to review before we go on is, of course, the substitution property of equality for real numbers and the distributive property of equality. The substitution property of equality says if A is equal to B, then A may be replaced by B in any equation or expression. If A is equal to B, then you can basically put A anywhere B is, and you can put B anywhere A is. Okay, so that's what the substitution property of equality says. The substitution property of equality for real numbers states if A is equal to B, then A may be replaced by B in any equation or expression. And finally, the distributive property of equality for real numbers states that if A times the quantity B plus C states that A times the quantity B plus C equals AB plus AC. Let me say that again because I messed it up the first two times. The distributive property of equality for real numbers states that A times the quantity B plus C is equal to AB plus AC. That's the old distributive property. Now, you should know these backwards and forward. You should be able to bring them out like old hat type stuff. Right? And don't forget that C cannot be equal to B. You can't divide by 0. That's not defined. Okay? So, addition property of equality for real numbers. Subtraction property of equality for real numbers. Multiplication property of equality for real numbers. Division property of equality for real numbers. Reflexive, symmetric, transitive property for equality for real numbers. Substitution property of equality for real numbers. Distributive property of equality for real numbers. And how do you state them? Addition property of equality for real numbers states that if A is equal to B, then A plus C is equal to B plus C. That you can add something to both sides of that equation and this equation still be true. Now, to this we shall add today 3 additional properties that we need to know. So, and they are about congruent segments. And here they are. Today I like to talk about properties of congruent segments. Okay, now look, we have all of these properties for real numbers. That is, you can say there's addition property of equality for real numbers. I corrected this over here. I was saying that, right? So properties of equality for real numbers. Okay, addition property of equality for all of these have an equal sign in them. All right. Now, what we have here is congruent signs. All right, so these are all congruent. So So these properties apply to congruent segments. That is, what can we say about segments that are congruent? So there are only 3 additional properties, and there are the reflexive, symmetric, and transitive. So you say this is the reflexive property of congruent segments. Reflexive property of congruent segment. This is the symmetric property of congruent segment. Transitive property of congruent segment. See, now you understand why we did the whole exercise of going through all of them properties so it comes out naturally. Because there are going to be so many of these and you can't just mix and match them. Follow what I'm saying? So we have 3 additional properties that we're going to learn today. One, the reflexive property of congruent segments. Reflexive property of congruent segments, symmetric property of congruent segments, transitive property of congruent segments. Now, also, that's one thing. So the phrasing of these will be slightly different. So we're going to say reflexive property of congruent segment. That's congruent segments. All right. Symmetric property of congruent segments. Transitive property of congruent segments. Get used to it. Reflexive property of congruent segments. Symmetric property of congruent segments. Transitive property of congruent segments. And then you're not going to say the reflexive property of congruent segments says A equals A. No, of course not. It's not A. That's a real number. A represents a real number. We're talking about segments over here. So here we're going to say that the reflexive property of congruent segment states, reflexive property of congruent segment states that a segment AB is congruent to itself, that is segment AB is congruent to segment AB. Easy enough. A equals A, AB, the segment AB is congruent to itself. Okay, so a reflexive property of congruent segment states that segment AB is congruent to segment AB. That means a segment is congruent to itself. And then we have the symmetric property of congruent segments. All right, so we have the symmetric property of congruent segments. Now, don't get the symmetric confused, with substitution, etc. And right, so symmetric property says, so symmetric, S-Y-M-M-E-T-R, symmetric property of congruent segments. Symmetric property of congruent segment, that's the second one over here, states that if if segment AB is congruent to segment CD, then segment CD is congruent to segment AB, right? So it's just like it's like this one, see? If A is equal to B, then B is equal to A. Now you're not talking about real numbers. You're not talking about numbers. You're talking about segments, correct? So you're talking about congruent segment. So the symmetric property of congruent segments, symmetric property of congruent segment states that if segment AB is congruent to segment CD, then segment CD is congruent to segment AB, correct? And finally, the transitive property of congruent segments. Transitive property of congruent segments, as you can imagine, states the following. Transitive property of congruent segments states, transitive property of congruent segments states that if segment AB is congruent to segment CD, that's like saying if it's like if A is congruent to B, right? If A is congruent to B, if segment AB is congruent to CD, and segment CD is congruent to another segment, let's say EF. So here we were saying, see, A equals B and B equals C. AB is equal to CD, and CD is congruent. Segment AB is congruent to segment CD, and segment CD is congruent to segment EF. So if segment AB is congruent to CD, and segment CD is congruent to EF, then segment AB is congruent to segment EF, like this. Ta-da! That's easy as pie. So the transitive property of congruent segment states that if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. I'd like to bring to your attention again that these are congruent statements. See, this, as I said, these can get complicated. It's no longer A equals B and B equals C, therefore A equals C. As you can see, the statements are more like cluttered, and you should be able to see it's not always as easy to see transitive properties in these cluttered statements, so to speak, because there are a lot of symbols here. But as you can see, there's something that's common to both of these statements, something that's overlapping, or something that can act as a bridge. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to AB is congruent to EF. Now, as I said again, don't be confused if the statement is written slightly differently. If it's written like AB is congruent to CD, and then instead of CD is congruent to EF, and EF is congruent to CD, right? Then again, AB is congruent to EF. The reason this is true is because the same transitive property of congruent segments, transitive property of congruent segments. Again, you should look for overlap here. There's an overlap in the bridge, something that's common to both of these statements. That acts as a bridge so these two can shake their hands, so to speak. So CD acts like a bridge for AB and EF, so they can shake hands. They can say AB is congruent to EF. Okay, so now these are 3 additional properties that we learned, and we're going to use these properties for in the proofs in our next class, inshallah. So before I finish, and I hope you're not tired of me repeating all of this, because it is kind of cumbersome probably to hear this than actually to say it on yourself. But if you can say it with me, that might be helpful for you. Anyway, so there are 3 additional properties that we learned. So you should be able to articulate all of these properties of real numbers like this. Properties of equality for real numbers, okay? And properties of congruent segments. So if somebody asks you, what is the property of transitive property of equality for real numbers? You should say, transitive property of equality of real numbers states that if A equals B and B equals C, then A is equal to C. And if somebody were to ask you, what's the transitive property of congruent segments? Then you say the transitive property of congruent segments states that if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. These all seem very intuitive, but for some reason students have a hard time articulating these. But I request that you take the time to memorize them and be able to articulate, speak them out, and relate to them, because it makes conversations much easier in geometry, and it makes proofs more elegant and easy for you. Inshallah, until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.